Yeah.
Yes, it does.
Hopefully it goes by fast.
Mhm.
Okay. You ready?
All right, I'm ready. You guys all ready?
I'm ready.
Awesome. Let's do this. Okay. Part.
Ashlyn joining us with this one.
Yeah, I'm here.
She's here.
Oh, she is. Okay, I just don't show her as being here.
She's just really tired.
Perfect. Oh, there she is.
There we go. All right. Part 2. Suppose Apple, computing sold an average of mean equals 45 p phones, per minute in 2011. Yes, that means they sold 23,652,000 p phones in 2011, which is probably like the same number that iPhones were sold. With a standard deviation of 10, they looked at their p phone sales data and determined they are normally distributed.
So
Well,
they're
that's
normally
not like
distributed.
they have a large sampling or anything. Question 4. Samples of size n equals 4 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of X?
Should be normal, right? Because it's normally distributed.
Yes,
Correct.
it was normal.
I'm so glad that that's a rule because I feel like that's like the catch-all.
5. Sample sizes of n equals 40 are taken from the sales data. What is the shape of the distribution? Normal.
Normal.
6. A sample size of n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed X is less than 40? Oh, less less than 40 were sold per minute. What is the probability? So we can go to the applet, but it's because the standard deviation is 10, so it's half of the standard deviation is what we're dealing with. So all we got to do is get the applet out, right? Punch the numbers in.
No, this is where you need to do the z-score, the x bar minus the mu, divided by the standard deviation, divided by the square root of n.
So get the z-score, and then take that to the applet.
Yeah.
Yeah.
But what number do you plug in for X for the z-score? Just any number that's less than 40 or just 30?
No, x is going to be 40.
X will be 40.
Yeah.
Okay.
Yep. So we will do, what is it, 40 minus 45.
Yep.
All over 10 over the square root of 4.
Yep.
So 5 over 5 equals 1. And that gives us the z.
Isn't it negative 5 over 5 because you're doing 40 minus 45?
Yeah, so it's negative. I got negative 1.
So it's negative 1.
Negative. Yeah, sometimes I ignore those little dashes.
Minor detail.
Okay, so negative 1 equals z, which means we have a 68%. So anything less than that, so we've 32% left, which means 16% are going to be less than 40, right?
Correct.
Okay.
That's what I got.
Wait.
So,
Okay, you guys are really fast. So.
okay, here. Want me to explain?
Yeah. So I got the z-score part, and then what do I do with it in the applet?
So score is negative 1. So whenever there's a z-score of 1, or in this case negative 1, what is the percentage? Do you remember what 68, 95, and 90? What is it? 97.5 stood for?
Oh yeah. Okay. It's all coming back to me.
Okay.
But
So in this case, we're 1 z-score away, so that would put us at 68% of the population. And so that's the center 68%, which leaves 32% on the outsides. Now, since this is normally distributed, that means that the outsides are going to be equal. So we can divide that 32 right down the middle, leaving us with 16% on either side. So in this case, that x is less than 40, it's going to be 16%, or 0.16 probability. Does that make sense?
Kind of. I'm kind of reading through it too with the explanation. So it's -2.
Or if you just type in -1 into the applet and select the left side, so that just the left smaller portion is selected, then the probability will be shown up in the area at 0.158.
And then you just round it.
Yeah.
Okay, I see that. That's just really smart tonight. So
I know, that smart junk I don't understand.
I'm like, where did he get 30? I was dividing 32 in half, and I'm just trying to read it and try to.
I got you.
But I got it.
Sorry.
Oh no, it's great. It's different perspectives because once you get it, like what the basic way is, it's kind of nice to see how it all connects. So that's awesome.
Okay. All right. Are we all good then with number 6?
Yes.
All right. We'll go to number 7.
Oh, I thought we were on 7. That's why I was so confused.
Awesome.
Yep, that's how lost I was. I kept trying to find the 32. Okay, I'm ready for 7.
A sample of size n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed x is greater than 35 and less than 55? That'll be 0.68. Because when you look at the standard deviation is 10, so 45 minus 10 brings you to 35, plus 10 brings you to 55. And so since that's one z-score away, or one standard deviation, it's going to be 68%, or 0.68 probability.
I like it.
All right.
Wait, explain that again. How did you do that?
So when we look at z-scores, well, I guess it doesn't really matter about z-score. When we just look at standard deviations, one z-score away is 68%. Two z-scores is 95, and after that 97.5, right?
Okay.
Yeah. So as long as they're equal.
Or 99.5, I forgot which one.
I don't remember then.
Yeah. But what happens here, since 35 is one z-score away, because it is one full standard deviation away, because the standard deviation is 10. Same with 55, it's one away. So we are within that range of that 68%. Does that make sense?
Okay,
It only works like that this time because the standard deviation is 10. And so it just happened to coincide that they happen to be one z-score away from each other, and that 45 would have been the median or whatever.
Because when you do it out on a calculator, you get -2 and 2.
Yeah, but you have to plug in that -2. You have to do probability. So would it end up being the 95 then if it's 2? If the z-score is 2, then that's 2 standard deviations. Right? Or am I just
So you do the in between the 35 and the 55, and you get 95 or 0.9545.
The answer sheet says 95 as well, 0.95.
Okay.
So I guess that
That makes no sense.
Though, Matt.
Huh?
I said your math made sense to me too, though. So apparently I'm just.
Yeah, that doesn't make sense to me because it is within one standard deviation away.
I think it went like I don't know. I thought I went out, so like it's within one standard deviation, but on both sides. So that way That would make sense why it's 95. I don't know. I can't explain. I like can't use my words. Sorry.
That's just the way we're gonna have to look at it, I guess, until it's proven wrong. Is that it's from both directions instead of
Yeah,
just.
because didn't it say between
Yeah, because you're looking at the between the
the 35
35
and 55? So you went.
So the area in the middle.
Yeah, I don't understand that problem. That doesn't make sense in my mind.
Well, if we do the math then and get the z-score for like just one of them and plug it in, it's obviously the same. You just
Well, that's
solve and get 2, and once you found out that the z-score was 2,
Yeah, I guess it is. That's interesting. So the z-score isn't equal to the standard deviation?
No. It's not. So the standard
That's where I
deviation.
was wrong. I was under the impression that
Yeah, no. They're different. So like,
that's
okay,
why.
so this might be a weird example, but so you'd have on a ruler, you have like your inches, and so every like mark, like every inch. So every like 1, 2, 3, those are your inches. So think of that as kind of like your standard deviation, and then your z-scores are kind of like the parts in between your inches. Like they kind of fall in between. So it's like does that make sense? Like it's a part in between each, like the standard deviation. It's kind of like you find out like where it is on the graph. It's not exactly on the standard deviation, so it's like it falls. But as z-score, it tells you like where it falls on the graph. Does that make sense? That's probably a really bad analogy.
I get the general grasp of it.
Yeah.
good teamwork, guys.
Okay. No, now well, when I'm sitting here doing the math by hand, and yeah, it's -2 is the z-score.
I still think you're brilliant, Matt, because you were able to convince me that you were still right.
Sorry.
No,
I
it's
don't know if
right.
that's a good thing.
Multiple, apparently. So, I mean, you obviously have a grasp on it. It's just a different.
Well, I had a bad definition in my mind. I thought that z-score was equal to standard deviation, and so I'm glad I cleared up right now.
Well, just make sure you keep in mind that in order to get the z-score, you have to divide by the standard deviation. So,
Yeah.
it's not going to be totally proportional.
Oh, no, that makes sense. You're right. Okay. So 0.95. Okay. So for 8, a sample size of n equals 25 is taken from the normally distributed data. What is the probability that x is greater than 41 and less than 49? 41.
Here's z-scores.
Mm-hmm.
So -0.8 and 0.8 on the z-scores.
I got -2 and 2 again.
For 41 and 49?
Yeah.
Wait, you're right, because I didn't change my n. So it would be -4 over 10 times the square root times 5.
So it'd be -4 divided by 2, right?
Yeah, so it'd be plus and minus 2, right?
Yeah.
That's what I got.
Yeah.
So if it would just be the ends then, right, and not the middle.
So what is greater than 41 and less than 49? So it's the exact same thing as 7, so 0.95,
Yep.
right?
Yeah, that's what I got.
Okay.
And that is what the answer key says.
Yay.
Cool. For 9, we have a sample size of n equals 25 is taken from the data. What is the probability that x is greater than 50? So it's 2.5 is the z-score.
Yep, that's what I got.
Yep.
Do we have a? Does anyone have an applet up?
I got 0.0062.
That's exactly what I got. Is that right according to the answer sheet?
Yep, you're right.
Is that what the answer sheet says?
0.00621.
Yeah, I think we are done for the. Maybe.
Now we have to do it again.
Now we've got, yeah.
It looks
Okay.
like we're going through graphs again at first, at least.
Mm-hmm. So pair computing sold an average of 40 for the mean P-phones per million in 2010 with a standard deviation of 12. And they looked at their P-phone sales data and determined that the distribution is right skewed. Okay. Let me just write this down. Equals 40. Okay. Yeah, equals 12. All right. 10. Samples of size n equals 4 are taken from the right skewed 2010 P-phone sales data. What is the shape? Right skewed.
Right.
For 11, we have sample sizes of n equals 40 are taken from the right skewed data. What is the shape of the distribution data? That should be high enough to be normal, right?
That's what I
This
said.
is with the average, right?
Huh?
I guess I'm just confused on if it needs to be higher than the average, and if it is the same, is it going to be considered? Oh, I'm just going to read my note really quick, I guess. Hang on one second.
Well, you're fine.
Yes. So that's it. Has to do with that CLT rule. Yeah. So it's approximately normal.
Okay.
Oh, and then I just answered this one for 12.
Okay. 12. Is there a theorem that justifies? Yeah, that would be CLT, right?
Yep.
Central
Limit theorem.
limit theorem.
Yeah.
Awesomeness. Okay, for 13, the sample of size n equals 4 is taken from the right skewed 2010 P-phone sales data, and you want to know the probability that the observed of x is less than 35. Can you compute this probability using the normal probability applet with information you have? Why?
I put no because it's a right skew. Where the applet is for bell shape.
No, you can't. You're right.
Yeah, I agree.
No, because the applet is for normal distribution. All right, 14. The sample size of n equals 36 is taken from the right skewed P-phone sales data. What is the probability that the observed x is greater than 36.5? Let's see. Work this one out. What's the? Do you guys know what the equation is?
Isn't it 36.5 minus 40 all over 12 divided by the square root of 6?
Yeah, that's what I got.
We've got the negative 3.5 over
6, I guess. Sorry. The square root of 36, which is 6. Sorry, I just plugged that in.
over 2. So negative 3.5 over 2.
Yeah.
3.5 over 2. Okay, which is, let's see.
Negative 1.75. Let me just plug that into the applet. So then you would do both sections because it was the negative 1.75, right? So it'd be the middle and the far right.
Yes.
Yeah.
So you guys got the 95 rule again?
Yep.
0.95, huh? Yep. And 15. The sample size of n equals 36 is taken from the right skewed 2010 pphone sales data. What is the probability that the observed x is between 37.5 and 42.5? So I got negative 1.25 and 1.25.
Yep.
When we plug it into the applet, what does that get us?
0.7887.
Wait. It's between it. I just got 0.7909.
Okay.
Oh, no, I didn't. Apparently I typed a 6 in.
Oh.
On accident. I don't even know how that's possible. Oh. So you guys got 0.7887?
Yeah, that's what I get when I put it in.
Cool. Awesome. Sounds good to me.
Okay.
And that's the homework.
Yay!
Not the homework, the preparation. We gotta do our homework still.
You guys ready?
Yep.
All right. Group meeting quiz. Let's see how many questions we have.
15.
No, it's not horrible. True for the first two. Okay. Start with 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Round to the nearest 3 decimal places. And
On the middle section? Right?
So we just want the middle section?
no, we wanted the outsides.
That's
Right of positive and left of negative.
Okay. So that gives us 0.1745.
Yeah, that's what I got. So it would be 0.175.
Yep.
You with us, Ashlyn?
Yeah, sorry. Wait, what did you guys get?
We got 0.17.
1.7. Okay, sorry. Yeah, I didn't understand. Yeah, that's what I got. Sorry.
No, you're good.
You're good. All right. For number 4, the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weight of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean. What that then was observed in this example. Round to 3 decimal places. Answer is blank, blah, blah, blah. Okay. So, when we're looking for probability, so right now, our mean, the little funny U, is 185, right?
Correct.
Yeah.
Our standard deviation, or theta, or whatever it's called, is 26.7. Our x equals 177.6. When we want to find the extremes, so just like in number 3, we want the outside. Now let's use this to find z. Z equals 177.6 minus 185 all over. N equals 48, by the way. N equals 48. So we have all over 26.7 over times the square root of 48. Right? Is that how we get this z?
Yeah.
Okay.
Need to buy a new calculator.
You guys get it?
Okay, so what area do we want?
Do you guys get negative 13.303?
For
The z-score?
I got negative 2.0758.
I didn't get that. I got negative 0.04.
That's what
Negative 0.04 is what you got?
Yeah, but something seems funny.
Because, okay, so it's 177.6 minus 185.
Which is
All
negative
over.
7.4.
Okay.
Right? Or then, yeah, negative 7.4. That's on top, is negative 7.4. On the bottom, we have 26.7 times the square root of 48, correct?
No, it's divide.
Divided by, oh, that'd be my problem. Okay.
I got mine
I
wrong.
got negative 1.920.
Give me 1 second to get 48 square root.
Yeah, I'm still backtracking as well.
So,
Yeah, negative 9.20.
26.7 divided by 0.928 323.
Okay, I got 1.920.
That's what I got. But it's a negative, correct?
Yeah.
Yes, it is. Well, you know, either way with z-scores, it's the exact same thing on either way to use the apple. So,
Right, as long as you plug it in the right side of the apple.
yes. Yes, that's true.
Negative 1.920, right?
Mm-hmm.
Make sure I did that right. And then we plug it into our graph.
And then we just do the extremes. Right?
On the outsides.
So that'd be
So
0.0549.
yeah. But it would be 0.055 because we're rounding.
That
Yeah.
is correct. It would take a lot longer. All right. So does everyone have 0.055 for number 4?
Yep.
Yeah.
Okay. Moving on. Number 5. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? Smaller The distribution of the individual observations, right? Because by that they mean the population, or no? This is confusing lingo.
I'm reading this on my notes.
I've got the mean of the mean equals the original population mean.
I don't know.
All my stuff is about means, not about the standard.
I know that's all I keep thinking, but I wasn't sure.
And I remember something in the reading, it said the mean of the means is equal to the standard deviation of the mean. I didn't write it down.
I wrote down that the standard deviation of the distribution is that weird equation, but I don't have it. All my other stuff is about means. Or like, here's the stuff about spread. If the standard deviation of the population is the standard deviation, then the standard deviation of the distribution of the sample means is the standard deviation divided by the square root of the sample size. And then it says the standard deviation of the distribution of the sample means is smaller than the standard deviation of the population by a factor of 1 over the square root of the sample. Does that help? Should I read that slower?
Yeah. Can you read it one more time?
Okay.
Please.
I think I'm just going to read the last part, because the last part. The standard deviation of the distribution of sampling means would be smaller than the standard deviation of the population by a factor of 1 over the square root of the sample size.
That sounds like it does, yeah.
Sounds right.
I don't know.
I almost feel like it's a trick question, because if you see it gives you the values of what they're talking about. So what they're saying is, are we going to have a smaller deviation with x or x bar? So the
I
absolute
didn't see
value of
that.
or just x. And I thought in observations you couldn't have negatives. I don't even get the x bar, but
Yeah, me either.
I think that they should be the same, which makes me think that it's the last one. This cannot be determined, but okay, so I wrote down a graph from the slideshow. So in the graph was an applet thing for a really small, there was just one subject, and so it was really small. It had like a little baby hump. And the standard deviation for it was 7. But when there was 10 subjects, there was that bar X, and the standard deviation was 2.2, and it was like really tall and steep. And so I'm thinking that maybe it's the X bar. Does that make sense? Did that graph explanation make sense at all?
So I'm just trying to think. So is the standard deviation smaller in a population or in a sample? I think that's the real answer to the question, right?
Yeah, probably.
So the individual observations are the entire population, but the distribution of the sample means is not, or is that the other way around? Does that make sense?
Yeah.
I'm trying to remember what's smaller.
Well, it says the standard deviation of a distribution versus the sampling means is smaller than the deviation of the standard deviation of a population. So
That's true.
yeah, so I mean that's straight from the notes. So we just have to figure out how to apply it to this example.
Can you read that again?
Yeah, the standard deviation of the distribution of sampling means is smaller than the standard deviation of the population by a factor of 1.
Okay, I think I get it. So it's going to be the distribution of the sample means X because the sample, I don't know.
I think that's right.
Because I think when you do the sample, it kind of goes with like the central limit theorem. Like the more you have, the more closer to the mean you are, which means like the less you deviate. So that's why it's a smaller deviation. Because
That makes total sense because we're already averaging.
yeah, and when you do a population, you just take like a small population of the sample, and because it's like a smaller,
There's more skewed values.
yeah, I think that makes sense. That sounds familiar.
And it makes logical sense.
Yeah, but see, that's just my sense, so don't go me. But yeah, but I think when you read that, that's what made sense to me.
Okay. Is everyone good with that? The distribution of the sample mean?
Yep.
So it's the distribution of sample means X bar.
Yep.
Yeah.
Okay.
All right. Let's go on to 6.
Yeah.
Which of the following results implies that the spread in X bar increases as the sample size increases?
Wouldn't that be spread?
Wait, isn't that the rule of large numbers?
Yeah.
'Cause the law of large
Yeah.
numbers, as the sample size n increases, the sample mean draws closer to the population mean.
Correct.
So that means the sample mean, which is X bar, draws closer to the population mean, which is that weird U, which implies accuracy.
Yeah.
The law of large numbers.
Yay!
Go team.
Yeah. Almost.
All right. Scores on the quantitative portion of the GRE are approximately distributed. Okay, that's good to know. The mean of 150.8, standard deviation of 8.8. This is information to answer questions 7 through 10. 7. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Z-score for Diane. She got 160. So we got 160 minus
150.8.
50.8 all over 8.8
Yeah.
divided by how many people?
It doesn't say.
I think we're just getting a
So
z-score.
I think we're just
It's not probability.
Not probability, so it's just over 8.8.
yeah.
Oh, we're just
Nine.
getting the justs, right?
9.2 over 8.8
What?
or whatever.
Yeah,
So
9.2 over 8.8.
Oh. Okay, got it.
So 1.045.
Yeah. Okay. Yep. That's what I got.
And then we have to plug that in.
So what is that again? 9.2 over 8.8. What was the answer? What did you guys get?
I got 1.04545.
Yep. So 1.045 if we round to 3, correct?
Yeah.
Yeah.
Okay. We'll go to 8.
So is that our answer?
Yes.
Yep, that's the z-score.
Okay. Oh, yeah, that's right. I was plugging it into the applet, so into the z-score on the applet. So.
That's what we normally do, but for right now now we have to do that weird probability stuff.
Okay, what is the probability that a randomly selected student will score above 160 on the GRE?
What is the probability that
Can we just use this is not her z-score and then above?
Exactly.
Yeah.
1.045.
I got 1.048.
Yeah, I got that.
Wait, but isn't so the probability isn't that the area on our applet? It's not the z-score. We plug the 1.45.
No, yeah, that is the error.
Yeah.
0.148.
Yeah, that's what it is for the area. 0.148.
148.
Mm-hmm. Okay. And for this one, we have number 9. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these students' scores? Okay, so with this we have n equals 5. Make sure we write that down. And then to get the sample mean, we'll add them all together and divide by 5.
So I got 160 again.
I got 160.
So it's 160? Okay, 160. All right.
So we already did that though, so it'd be 1.045, right?
Well, no, because when we
Now we
do
divide by
We now have n.
over the square root of 5.
yeah. 'Cause it's
Yay. And now we go. Now comes the other part.
Yeah.
Awesome.
Okay.
You guys get 5.227?
No.
I got 2.337.
2.2 or 2.337. That's what I got.
Hang on. What did I do wrong? So what did you guys get?
I got 2.337 as well. In this case, 2.338 when we round. For the z-score.
Okay.
Is everyone good on that one?
Yeah.
I think what I was doing wrong is I was using the old mean.
Oh.
160 minus 160, right?
I did 160 minus 150.8 because aren't you subtracting the mean from the sample from the mean from, or mean from the like random sample from the mean from the actual like
Yeah.
the sample. So
So
you're
160 minus 150.8 all over.
8.8.
Now I'm confusing myself. The standard deviation. 8.8. Okay. Got it. Got it.
I think.
2.338.
Yes.
Okay.
All right, number 10. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
It's greater than.
Probability greater than. So 2.338 to the, whatchamacallit?
To the right.
Applet.
Yeah.
So that is
0.0097.
that's what I did.
.00. So
Wouldn't it be?
.01.
Yeah. Would it be .010? Cause
But it says round your answer to the 4 decimal place.
oh, 4. So okay, so it's 0097.
Cool. Good job reading that.
Yes.
Cool. 0.0097. Okay, that's for 10. Okay, suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. Okay. It is well known that the distribution is less skewed. A random sample of n equals 81 students will be drawn. Use this information to answer problems 11 through 15. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of 81 students who are selected? Should be normal, right?
I'd say approximately normal.
Approximately normal.
Yeah, because your sample size is 81.
I agree.
Sorry, what was that?
So because the sample is so high that we're distributing, find the sampling distribution for the mean. We're going to go with approximately normal, right?
Yeah.
Okay.
Just want to make sure. That's what I heard. So okay.
Epic. 12. What is the mean of the distribution of the sample means, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population?
So what is the mean of the... Isn't it the same mean? The mean of the means is the population means.
So the 3.5.
Yeah. Right?
That's what I was thinking.
So that's right. The mean of the distribution.
And it says round your answer.
Say that again. Sorry.
So in my notes I have written down that the mean of the means equals the population means. So u to the x bar equals just that weird u. So 3.5.
3.5. All right.
And it says round to 1 decimal place. So.
So 3.5 for 12?
Yes.
All right. 13. What is the standard deviation of the sampling distribution of the random variable x bar, the mean of the 81 students who are selected? So what is the standard deviation for that, for those 81 students?
Then we already decided it was the 0.7.
So it would be
That's right.
0.7 over the square root of 81. So 0.7 over 9 equals the standard deviation of that. Remember? Because we have an n equals 81 here.
Yes. Yes. I have that written down.
0.7 over 9.
So you get 0.0777.
Yep, 0.77. And how many spaces are we going? 3?
Wow.
0.78.
Whoa.
0.078, sorry.
0.0.
0.078 for 13.
Wait, you guys got 3?
The what?
Round your answer to 3. So if
I
it's
got-
778.
So I got 0.078.
Yep. 0.078.
Okay.
Yeah.
Sorry, I kept hearing you guys say like 3 point something, and I was like, that's so not what I got. But never mind.
You're good. It's late. I understand.
It's a lot later here. That's
I
my.
know. I feel bad. It's like
Okay.
10:30. Let's get everyone to bed. 14. What is the probability that the mean GPA for 81 randomly selected BYU students will be less than 3.3? Round your answer to blah 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 blah. Okay.
Be like our X, right?
Yes.
Yeah.
So 3.3 minus 3.5 over 0.7, which is over the
The
square root of 81.
0.07.
So 0.0777777. So we've got negative 0.2 divided by that.
You guys get negative 2.572.
I got negative 2.571428498.
2.56. What did you get?
Negative
Sorry, you guys got negative?
2.571.
Oh,
Negative-
perfect.
Sorry, negative 2.571428498.
Yeah.
Okay.
I'm so sorry. So you guys are putting negative 2.574, or what was your third decimal place?
It was a 1.
1.
What I took was negative 0.2 over 0.077777778.
Oh, wow, so you really went out there. So
I
you
went
got,
out, and that reduced that number down a little bit, I think.
Yeah, it did, because I got negative 2.561.
okay,
Yeah.
so negative 2.571.
Mm-hmm.
Yes.
Got it.
And then we put that on our probability output, right?
Yep.
Okay. Do you guys get 0.0051?
Wait, so what are we?
What's the question say? What is it?
And what probability are we trying? What
Isn't
is
that
it?
less than 3.3?
Less than those.
So we're going to the left.
Yeah.
So 0.0051.
Perfect. That's what I got. And then it says 3 decimals, so 0.005.
Okay.
Is that for 14?
And then for 15, that's for 14. All right, guys, last problem.
What did you get for 14?
0.005.
0.005. Okay, that's what I got.
For 15, what is the probability that the mean GPA for 81 random students will be greater than 3.3? Oh,
It's like this, the middle and the end, right?
yeah, well, that's an easy.
Yeah.
That was easy. 0.995.
995.
Which means, yeah, 3 standard deviations. All right, 0.995. Is is everyone good with everything? We feel comfortable? Anything we need to readdress?
Here we go.
All right.
Okay, submit.
I'm nervous.
Me too.
Woo!
Oh, I got an A! Nice!
Good job, everybody.
Awesome. Good job, guys.
Mine's still submitting.
Work.
Well, surprise! Spoiler
Epic
alert.
work.
We got an A.
Good job,
I'm gonna be
everybody.
so mad if it doesn't go through. Oh, yay! Awesome, guys. That was some serious teamwork on that one.
Yeah.
You did a great job. That was sweet.
I
Yeah,
really
good job.
needed those points. My homework killed. Okay, guys. I'm gonna post this one, so we'll have it all done, and I will see you guys next week.
All right. See you next week. Have a good week, everybody.
Bye.
See ya.
Night, guys.
Night.
Night.